Hello everyone, welcome back to my channel. Today, I want to talk to you about an exciting area of research called RLHF, or reinforcement learning from human feedback. ChatGPT, or Generative Pre-trained Transformer, is a powerful language model developed by OpenAI. It has been trained on a massive dataset of text, and it can generate human-like text responses to a wide variety of prompts. So, what is language model pre-training? Essentially, it's a technique where we train a large language model on a massive dataset of text, and then we use that model as a starting point for fine-tuning on specific tasks. And the reason why this is so powerful is that a language model that's been pre-trained on a large dataset of text, like the internet, has already learned a lot about the structure and patterns of language. So, when we fine-tune it on a specific task, like language translation or question answering, it can learn to perform that task much more quickly and effectively than if we were to start from scratch. So, what is unsupervised sequence prediction? It's a technique that uses machine learning to predict the next word or next sequence of words in a given text, without the need for labeled data. It's called unsupervised because it doesn't require any labeled data to train the model. And the reason why this is so powerful is that it allows the model to learn the structure and patterns of language from the data itself, rather than relying on labeled data. This is particularly useful in cases where labeled data is scarce or expensive to obtain. One of the most popular unsupervised sequence prediction techniques is called language modeling, in which the goal is to predict the next word in a sentence given the previous words. This technique is used in many natural language processing tasks such as text generation, machine translation, and text summarization. One of the main challenges is dealing with overfitting, as the model may memorize the labeled data rather than generalizing to new data. Now, you might be wondering, where did OpenAI get all that data to train GPT-3? Well, they used a combination of public and proprietary datasets. One of the main sources of data used to train GPT-3 is the Common Crawl, which is a publicly available dataset that contains billions of web pages. They also used Wikipedia, which contains millions of articles and is a great source of structured and unstructured data. Another dataset used to train GPT-3 is the Open Web Text, which is a dataset of web pages that have been filtered to remove low-quality content and to ensure that the data is suitable for training a language model. In addition to these public datasets, OpenAI also used proprietary datasets from their partners and clients, which allowed them to fine-tune GPT-3 on specific tasks and domains. So, what is supervised fine-tuning for pre-training? Essentially, it's a technique where we use a pre-trained language model, like GPT-3, as a starting point, and then we fine-tune it on a specific task using labeled data. For example, let's say we want to train a model to do sentiment analysis on movie reviews. We can start with a pre-trained language model like GPT-3, which has already learned a lot about the structure and patterns of language, and then fine-tune it using a dataset of labeled movie reviews. This way, the model can learn to perform the specific task of sentiment analysis more quickly and effectively than if we were to start from scratch. In GPT-3, the transformer architecture is used to generate text that is similar to the training data. GPT-3 uses a transformer architecture with 175 billion parameters and 12 layers, which allows it to generate very human-like text. Self-attention is a mechanism that allows the model to focus on specific parts of the input when making predictions. Essentially, it calculates a weighted sum of the input's hidden states, where the weights are determined by the similarity between the input's hidden states and a query. This is different from traditional architectures like RNN and CNN, which use a fixed-length context to make predictions. The self-attention mechanism allows the model to focus on the most relevant parts of the input, regardless of its length. The transformer architecture is composed of an encoder and a decoder. The encoder takes in the input text and produces a set of hidden states. These hidden states are then used by the decoder to generate the output text. One of the key innovations of the transformer architecture is the use of multi-head attention, which allows the model to attend to different parts of the input text simultaneously. This allows the model to learn more complex relationships between the input and output text. Another key feature of the transformer architecture is the use of position encoding, which allows the model to take into account the position of each word in the input text. This is important because the order of the words in a sentence is often important for understanding its meaning. So, what is a prompt? A prompt is a piece of text that the GPT-3 model uses as input to generate a response. It could be a sentence, a question, a paragraph, or even just a few words. The prompt serves as a starting point for the model to generate text, and it can be used to control the content and style of the generated text. For example, if you give GPT-3 the prompt "Write a story about a robot who wants to be human," the model will generate a coherent and consistent story about a robot who wants to be human. If you give the same model the prompt "Write a poem about the moon," the model will generate a poem about the moon. After the model has learned the structure and patterns of language by unsupervised learning, a reward function is defined to evaluate the quality of the generated text. The reward function takes into account factors such as coherence, consistency, and similarity to the training data. The model then generates text using the current prompt, and the reward function is used to evaluate the quality of the generated text. The model receives a reward based on the evaluation, and this reward is used to update the model's parameters. This process is repeated many times, and the model learns to generate text that aligns with the reward function, resulting in text that is similar to the training data. Reinforcement learning, or RL, is a type of machine learning that involves training an agent to take actions in an environment in order to maximize some notion of cumulative reward. Reward models are an important concept in reinforcement learning. In RL, an agent interacts with an environment and learns to take actions that maximize a cumulative reward. The agent does not know what actions will lead to the highest reward, so it must explore the environment and learn from its experiences. A reward model is a function that estimates the expected reward of taking a particular action in a particular state. It is used to predict the reward an agent will receive for taking a certain action, based on its current state. This prediction is then used to guide the agent's decision-making process. One of the crucial components in reinforcement learning is the reward prediction, which refers to the agent's ability to predict the reward of an action before taking it. Reward prediction helps the agent in learning the best action to take in a given state by predicting the reward it will receive. So, what is a reinforcement learning policy? Essentially, it's a function that maps the current state of an agent to an action. It's used to determine the action that an agent should take at a given time, based on its current state and the rewards it's trying to maximize. The policy can be deterministic, which means it always returns the same action for a given state, or it can be stochastic, which means it returns a probability distribution over the possible actions. In reinforcement learning, the policy is learned through a process called policy optimization, where the agent tries different actions in different states and updates its policy based on the rewards it receives. One of the most popular methods for policy optimization is called the policy gradient method, which is a type of gradient-based optimization. It works by using the gradients of the expected rewards with respect to the policy parameters to update the policy. PPO is a method that allows an agent to learn and make decisions more efficiently by making small adjustments to its current policy, rather than making large, drastic changes. This way the agent can learn from fewer examples and still make good decisions. So, what are these components? Essentially, the generator and discriminator are two neural networks that work together to improve the performance of GPT-3. The generator is responsible for generating text, and the discriminator is responsible for evaluating the quality of the generated text. The generator is trained to produce text that is similar to the training data. It takes in a prompt, such as a sentence or a question, and generates a response that is coherent and consistent with the prompt. The generator is trained using unsupervised learning, which means it learns to generate text without any labeled data. The discriminator, on the other hand, is trained to evaluate the quality of the generated text. It takes in a generated text and a prompt and decides whether the text is coherent and consistent with the prompt or not. The discriminator is trained using supervised learning, which means it learns to evaluate text using labeled data. The generator and the discriminator are trained together in a process called adversarial training. The generator tries to generate text that can fool the discriminator, and the discriminator tries to distinguish the generated text from the real text. This process allows the generator to improve its ability to generate text that is similar to the training data, and the discriminator to improve its ability to evaluate the quality of the generated text. The main difference between GPT-3 and ChatGPT is the fine-tuning process. ChatGPT is fine-tuned on conversational data, which allows it to generate responses that are more relevant to the current context of the conversation, while GPT-3 is fine-tuned on a general text data. In simpler terms, GPT-3 is great at generating text on a wide range of topics, while ChatGPT is great at generating responses in a conversation. I hope you found this video informative and interesting. If you want to learn more about ChatGPT and its applications, make sure to subscribe to my channel and hit the notification bell so you don't miss any updates. And as always, if you have any questions or comments, leave them down below. I'll do my best to respond to each and every one of you. Thanks for watching, and I'll see you in the next video.